Ionic compounds, part 3. Transition metals and nonmetals, Science 10, Chemical Reactions, video 5. Transition metals. They have two naming systems, and these compounds can be named two different ways. So we have the IUPAC system, which also is known as the Stock system. This is a more internationally accepted system. It involves transition metals that are found from groups 3 to 12 on your periodic table. IUPAC stands for International Union of Pure and Applied Chemists. This system places the oxidation number, also known as your charge, in Roman numerals and in brackets between the transition metal and the nonmetal. So a reminder for Roman numerals, we have I for 1, II for 2, III for 3, and IV for 4. So that's 1, 2, 3, 4. The second naming system is known as the classical naming system. Classical system is an older system of naming that is still used and gives specific names and endings for oxidation numbers for transition elements. Mostly words come from Latin and Greek. This course we will not be using this system. Only the IUPAC system will be used. So the IUPAC, or Stock system, is a transition metal, a Roman numeral that represents the oxidation number or the charge, and a nonmetal with an ide. So, for example, we have copper 1 sulfate, which chemically looks like Cu2S. You can find typical transition metals on the back sheet of your representative periodic table, and we're concerned about the IUPAC ones. We will occasionally look at other transition metals, but these are the standard ones that we will look at for this course. And we don't have to worry about classical. All you need to know is the name and that it is the second type. Alright, transition metals and nonmetals. So, let's go through the steps. First, we need to identify the charge of the nonmetal. These are always charges that you can find. You can look under your anions on your list on your representative periodic table, or if you know the group number, you can solve for the charge. So let's look at Cu, Cl. So we need to identify the charge. So what we do know is our nonmetal, and its charge is -1. So step 2 is to determine the charge on the transition metal by finding the overall zero charge. So my overall, because I have only one, essentially here and here, I have 1 chlorine, therefore I have to be -1. And therefore I have to be +1. Since I only have 1 copper, my copper has to be +1. So I look for copper +1 on my sheet, and that tells me that I'm copper, 1 Roman numeral, because I'm a +1 charge, and I'm not chlorine, I'm chloride. So important things to note, I have my transition metal, I have my Roman numeral, and I have my nonmetal, with the iod. So let's do another example. So say we have copper, Cl2. How will this change? Well, we know Cl2 has a charge of -1. So that means this side's overall charge has to be -2. Because I have two chloride, and since I have two of them, I add those up, and that equals -2. So that's how I got my 2, because I have two of those. That's what that 2 means. So, if that's my total overall charge on my negative side, my positive side, to make 0, has to be 2. And since I only have one copper, my copper has to have a charge of +2. So I can look on my sheet, or I can recognize that I have +2. +2 equals a Roman numeral 2. So I can write down copper, Roman numeral 2, chloride. Let's do another example. We're going to look at copper, 2 oxide. So we have charges to find first, so we find our nonmetal since we know it, and it's -2. We only have one of them, so I know it's -2 overall. So this side has to be +2. But since I have two of these, they each need to have a charge. So they each need to be +1, which equals +2, which works. So that means my charge has to be +1. So then I can write copper, erase this, copper, 1 oxide. Again, I can find this from my anions list. Oh, let's do one more example. Let's look at chromium, so CrF3. So, again, I start with my nonmetal, which is my fluoride, and I put -1. I have 3 of them, so I'm -3. Since I only have one chromium, this side has to be +3. And that means that each of my chromium have to be +3. So therefore my formula is chromium 3 fluoride. Okay, because again, my +3 means Roman numeral 3. So when we go the opposite direction, things change up a little bit. So with transition metals and nonmetals, I have to give you a balanced formula. I can't just give you a transition metal and a nonmetal, like I did before. This is the only way that you can find the correct name. But I can ask you to go from the word formula to the chemical formula. So let's do that. So we have transition metals and nonmetals. So we're going to start with our name. So let's say we have mercury 1 sulfide. Well, I can determine my charge on my transition metal just by looking at my Roman numeral. So I know that I have Hg +1. And I can look on my sheet and I know that S sulfide is S -2. So I can determine my overall charge has to be -2, +2 equals 0. So now I need to figure out how much I need. So I just need 1 sulfur will work, but because each of my mercuries is +1 and I need +2, I need 2 of them. So my correct formula would be Hg2S. Let's try one more example. We've got gold, 3 nitride. So I can look at here, and I know this has to be Au plus 3. Nitride is N minus 3. My charges are balanced, plus 3 minus 3, so I don't need any more. So I can just write AuN. And the last example is gold. I already did gold. So let's do iron. 2 bromide. So iron is Fe. This means plus 2, so I'm plus 2. Bromide is negative 1. So my overall positive 2, negative 2. I need 2 of these. Just need 1 of those. So my final is FeBr2.